All right, today we're going to talk about composite figures, section 9.3. Okay, composite figures are figures that are not exactly easy figures, but kind of made up of a bunch of like smaller figures put together, or a bigger figure with smaller figures taken away. All right, they're not perfect shapes though. Yeah. So composite figures, section 9.3. So here's an example of a composite figure. The figure I write is called a composite figure because it is made up of simple shapes. To find its area, first find the areas of the simple shapes and then add. For example, what we're doing here is I can take this shape over there to the right, and if I kind of cut it across right there, notice I can break it down into a triangle and a rectangle. Well, breaking it down into simple shapes makes it a lot easier to find the area. Why? Well, because I can find the area of the triangle, and then I can find the area of the rectangle, add them, and get the total complete area. Okay, so that's what we're going to be doing today. We're going to be trying to break these figures down into simple shapes. Now, a lot of times there's more than one way to break the figure down. That's okay. Okay, there's a lot of different ways you can break it down. Whatever way you see is best. You just got to make sure you compute it correctly. For example, this one, somebody earlier was like, well, couldn't you do a rectangle and a trapezoid? You bet. I could have done it that way. Okay, but maybe you don't like trapezoids. Maybe you see triangles as easier. It doesn't matter. Your choice. Okay. So number one here, composite figures. Number one says find the length of x. So as I look here, I have a big figure broken down into two smaller ones. What would the length of x be, Anna? What is it? It would be 8 inches. Nice job. X would come out to be 8 inches. Okay. Now I need to find y. How would you find the height of y? What would y be, Suitor?
6.
How would you find 6?
The whole length is 12. That's half of it.
Ooh. The whole length is 12, but you don't necessarily know for sure it's half. Even though it is, that's not the best way to say it. Do you know what you would say, Tiana? You don't know that either. Yes, because you don't want to subtract them technically.
You do know it's half, though.
You do not know it's half. It is half. You do not know for sure that the segments are half, though.
Yeah, because the whole thing's 12 and it's split.
Okay, so now that I have x and y, I need to find the area of the rectangle. So find the area of the rectangle. Area of rectangle is, remember, length times width. What is the area of that rectangle, Isabels? 48 inches squared. Nice job. And then number 4 says find the area of the marked trapezoid. Area of a trapezoid is 1/2 base 1 plus base 2 times the height, if you recall. So like the average of the bases times the height is usually what I say.
I have another question.
Yeah, sure. Okay, so there's my formula for my trapezoid. What is the average of my bases now? Base 1 plus base 2 divided by 2. What's the average of my bases here? What'd you say? 24, and you add them up, and then divide it by 2, and you get 12. Oops. And then I would take 12 times the height of 6. 12 times 6 gets me 72 inches squared. Now I want to find the total area. So to find the total area, I would add those two. 48 plus 72 gets me, anybody? 120 inches squared. And there is our final answer. So again, the composite figures, you don't have to either break them down into smaller, simpler shapes to work them out. Okay, and again, somebody even earlier was like, well, couldn't I have done, a rectangle and a triangle here? Yeah, you bet. You can do a rectangle and triangle there. You get the same answer. It's fine. You just got to compute differently. Okay, not a problem. Find what's easiest for you. Let's try number 6. Find the area of each figure, round to the nearest tenth if necessary. What two shapes do you see in number 6, Schultz? I see 2 rectangles, right? Great. So what's the area of, we'll say, the bottom rectangle here? What's the area of that bottom rectangle, Nathan? That is 96 meters squared. Awesome. Then I look at the top rectangle. What's the area of that top rectangle, Tigger? Area, sir. 80 meters squared. Now, how do I find the area of both of them combined? I would add them. And when you add them, you get a total area of what, Joe? 176 meters squared. Nice job. Now, problems like number 7. These problems throw people for some curves sometimes. Does anybody know why? Because the circle. Yeah, they struggle with the circle. Specifically, is this a full circle here? It's a half circle. You have to kind of remember that at the end here. So let's look at this here. First off, I have a triangle. How can I find the height of my triangle? Pythagorean Theorem. More importantly, it's a Pythagorean what? Triplet. What's the other side have to be? 4. Yeah, the other side has to be 4 here. Awesome. So I can find the area of my triangle. So my triangle area comes out to be what, Yanni? 6 kilometers squared. Awesome. Now I want to find my circle or semicircle area. Well, how do you find the area of a circle? Radius squared times the pi, right?
Yeah.
But to find the area of a semicircle, what do you have to do at the very, very end, would you suppose? What'd you say, Bailey? Divide by 2. So we're going to do the same exact thing we usually would. What's the radius here? 2. So 2 squared is 4. 4 times pi, or 4 times 3.14, because we want to go to the nearest tenth here. It's about 12.56, I believe. You get 12.56, or about 12.6. And because I want to take half of that then, I divide that by 2. And the area of my semicircle comes out to be approximately 6.3 kilometers squared. There's the area of the semicircle. And then how do I find the area of the total figure? What would you do with those two? You would add them, and I get 12.3 kilometers squared. Okay, and again, the circle will throw people for fits just because you have to remember the pi and everything else that goes along with it. Okay. Take a couple seconds, try numbers 8 and 9. Find the area of these shaded figures. Try these two. So number 8, broke it down into 2 rectangles. What's the area of the bigger rectangle, Emily? 420. Nice job. And then what's the area of the smaller rectangle, Amy? 30. Now I find the area of total. I would add those up, and that gets me 450 yards squared. Nice job. And then number 9. Same thing here. I would cut it up as a triangle and a rectangle. If I did a triangle and a rectangle, what are the base and height of the triangles, Yanni? 6 and 4. Which gives me an area of what for the triangle, Yanni? 12. And then I find the area of the rectangle. What's the area of the rectangle, Dylan? 90. And then what would you do with those two? You would add them, and I get 102 millimeters squared. Nice job.
Oh, it's still right.
Yeah.
I did the triangle thing, so the number, that's fine.
That's what we had. We did triangle.
No, I mean not triangle. I did the right.
Next thing we're going to do is still talking about composite figures, but you can also use subtraction with respect to composite figures. This is the one that was on our warm-up, actually. So to use it with subtraction, you want to find the area of the big one, and then you can subtract the area of the small one. Okay. Besides, if you didn't want to do that, you could also break it down into 3 parts and then add up all 3 parts. There's a lot of different ways to work these out, but sometimes subtraction works easier just as much. And then we can also estimate the area on a grid by drawing in kind of simple shapes like a square and a triangle, and then finding the areas of those. Okay, so that works as well. So try number 10 on your own. Find the shaded area, round to the nearest tenth if necessary. Notice number 10. It gives you a rectangle. You have a rectangle, and then you also have a triangle. Okay, so find the area of the rectangle, then subtract the area of the triangle. Try number 10 and 11. All right, let's look at number 10 here. First thing you want to do is find the area of the rectangle. What's the area of the rectangle, Reagan? 3 what? 396. And then I find the area of the triangle. What's the area of the triangle, Reagan?
Because I got 196 for one block.
You divide that by 2. Nope, just kidding. Should have got 198 divided by 2. What's the area of the triangle? 99. So to find the area of the shaded area, what do you do then? You subtract those. 396 minus 99 gets me the shaded area is 297 millimeters squared. And a lot of people are like, well, number 10, that's not a right triangle then. You don't need it to be a right triangle. All you need is the base and the height. The base is 22, the height is 9. Half the base times the height, same thing. Number 11. First thing you want to do is find the area of the rectangle. What's the area of the rectangle, Izzy? 45. Okay. Then I want to find the area of the semicircle there. Well, what's the radius of the semicircle, Yanni? 2.5. So to find the area of the semicircle, you'd have to do 2.5 squared, which is 6.25, times pi, which ends up being about 18.9. Oh, sorry, was it? 19.6. And then, because we're talking about a semicircle, I need to do what to that? Cut that in half. Divide that by 2, and I get about 9.8. So now I subtract those two. 45 minus 9.8 gets me then the area of the shaded region is about 35.2 centimeters squared. Okay, and again, notice that semicircles, you have to make sure you use the radius and square it. Okay. Same idea. Now you're going to estimate the areas on numbers 12 and 13. Now to estimate, again, just kind of draw in where you think it's going to be. So like number 12, well, that looks like it kind of makes this shape right here. Okay, use kind of straight lines to help you draw it in. 13, you can kind of looks something like this. And you are estimating, using figures, you can break it down into rectangles or squares or triangles. Break it down and find the approximate area of this. All right, number 12 here. What is the approximate area of this shape, Anna? It is about 8 centimeters squared. Again, you can cut down a lot of different ways. You can cut down as 2 rectangles if you want. Well, this rectangle has an area of 2. This one has an area of 6. 2 plus 6 gets me 8. You could have done the long rectangle and a square. Either way, you get an area that's approximately 8. Number 13, if you look at number 13, you should cut down as a rectangle and a triangle. Same idea. What's the approximate area of the rectangle? 6. What's the approximate area of the triangle, Nathan? 3. So what's the approximate area of all this then? 9 centimeters squared. That's all it is. Just approximating these areas. Okay?
How did you approximate the area of the triangle to be 3?
The base is 3, the height is 2. Here's your assignment.